Okay, good afternoon, class. I am Engineer Victor Omosu. I'll be presenting a sieve analysis test carried out on a river sand. And the following data was recorded. The sieve size was given. The sieve size was given in millimeter. The sieve size in millimeter. The weight retained was also given. The weight retained was given. The sieve size is 2.8. The first sieve size. The next is 2.0. I have 1.4. I have 1.0. I have 0.71 millimeter. That is 710 micro. I have 0.5, I have 0.3, and the pan. For the weight retained, I have, let me just make this. The weight retained, I have 0.00. The weight retained in grams, please. I have 0.00. I have 3.5. I have 76.0, 89.0, 80.0, 50.0, 34.0, and 12. So this is the weight retained by each of these sieves. So I was asked, I will plot a particle size distribution curve. I will calculate the coefficients of uniformity and the coefficients of curvature, and I will estimate the grade of the aggregates as well. So the first is to get the percentage retained. The percentage retained can be calculated by, say, we take this weight retained by the total weight. Once we sum this, we get about, when we sum this value, when we sum using calculator, we got 333.35 grams. Once this is summed, we get 333.35 grams. So this is the total value of the weight retained. So to get the percentage weight retained, the percentage cumulative weight retained is gotten by taking this value. You divide this value by this and multiply by 100 over 1. So once this is done, we get the value, this as 0.00, we got this as 0.99, we got this as 2.15, we got this as 27.72, and this as 22.63, this as 14.14, this as 9.62, and this as 3.39. So this is the percentage cumulative weight retained. So the next is to calculate the percentage cumulative passing. So the percentage cumulative passing can be calculated by deducting this value from 100%. So once this is 100, this 0 is taken from 100, we have this as 100. We can get 99.9, but it can be approximately equal to 100. So this, we got what? 19.01. This as 77.51. This as 49.79. This as 27.16. this as 13.02, this as 3.4, and this as 0. So this is the percentage cumulative passing. So at the end of this, if you don't get 0 at this at the last value, the pan value don't give you 0, then there is a problem. So to get a particle size distribution curve, this has to be plotted on the vertical axis on a linear scale. This has to be plotted on a vertical axis in a linear scale against the sieve size in what? The horizontal axis. You can use a linear scale for the both of them to make your work simple. So, to plot a particle size distribution curve, the percentage passing is plotted on the y-axis and the sieve size on what? The x-axis. So, let's get this diagram. Let's get the diagram for this. So we want to plot a graph of the percentage passing against the sieve size. So a graph of the percentage passing against the sieve size, a graph of the percentage passing against the sieve size. So this is the sieve size. The sieve size measured in millimeter. Please, the heading, a particle size distribution curve against what? The percentage cumulative passing. So the percentage cumulative passing is in percentage. So the vertical axis is in percentage and the horizontal axis is in what? In millimeter. So a graph of the percentage cumulative passing is plotted against the sieve size. That is the particle size distribution curve. So plotting this graph in a linear scale. When I mean a linear scale, the scale is linear. You can take 2 centimeters to 10%. Let 2 units or 2 centimeters represent 10% on this axis. And this, you can take 2 centimeters to represent 2 units to represent 1 centimeter for the x-axis. So when this graph is carefully plotted with what? A suitable scale, we expect a graph of this trend. A graph of this is produced. So now you have plotted your particle size distribution curve. This is the particle size distribution curve plotted. So to get, there are some parameters we can get from this graph. The finest modulus can be calculated. The finest modulus Fm is defined as the total weight retained, divided by 100. So the finest modulus from here is 333.35 divided by 100. That is about 3.33. So the finest modulus is about 3.33. So some other parameters like the coefficients of uniformity and curvature can be estimated from the particle size distribution curve. So the diameter at 10% cumulative passing. We have to get the diameter at 10% cumulative. Let's take this as 10%. So the diameter at 10% cumulative passing, then we do the tracing. Then the diameter at this point is known as D10. So the next is to get the diameter at 30% cumulative passing. That is around this point. Then this is D30. Please indicate this in the graph. It's very necessary. And this is 30%, and this at 60%. So you have to trace this to the curve. So this is D60. So to calculate the the coefficient of uniformity, Cu, the coefficient of uniformity is equal to D60 over D10. So the value, you have to take the value D60, the value you got here, the value you got at this point, and this point, you have to take them. Then you divide, then you get about 2.56 as the value. Then the next parameter is the coefficient of curvature, C sub C, and is given as D30 square over D10 D60. So we have to get the value for D10, D60, and D30. So when you impute this parameter, we get about 1.09. 1.09. So now we know the coefficients of uniformity and the coefficients of curvature. Now we can estimate the grade of the aggregate, that is the river sand. So the grade of this aggregate can be estimated with this value, the CC. So if we can estimate if the aggregate is well graded, if it's well graded, poor graded, and gap graded. So if it's well graded, the value of CC, if it's well graded, the value of CC will be in between 1 to 3. That is well graded. If it's poorly graded, then the value of CC will be outside 1 to 3. That it can be 0.99. Yes, it's poorly graded, and it can be 3.1. Then it's poorly graded. Then, if it's gap graded, the value of Cu must be greater than 4. If it's gap graded, then the value of Cu must be greater than 4. Thank you. If you find this information or this class helpful, please don't forget to subscribe to my channel. Thank you very much.